Okay, so I hope we're through the hard part of section 5.6. Greater than problems or greater than or equal to problems aren't really any different than less than problems or less than or equal to problems. So, and that's what 45 through 88 contain, all greater than or greater than or equal to problems. So when I'm trying to solve a quadratic problem, which is square, which we call a quadratic inequality in this section, a quadratic problem with a less than or equal to, or greater than or equal to, or greater than or less than. These are called quadratic inequalities still, even if they have greater thans. And when you have greater thans or greater than or equal to, what we have to worry about is a special case. And on this sheet that I worked with yesterday for me, the special case is if the left side is completely squared and the right side is a negative number, then that's going to be a special instance. So I'm going to look for and the nice thing about the special case problems, they don't require any algebra. So I like to have a bunch of those, really. And for greater than or equal to problems, the special case is you have something squared on the left side, and then either greater than some negative number, or something squared on the left side greater than or equal to some negative number. And if you don't catch a special problem and you start doing algebra, the algebra is going to produce an I, and then you'll know it's a special case you just missed. So for instance, something like this, x squared greater than negative 9, that would be a special case. Something like this, x minus 7 squared greater than or equal to negative 16. That's what the special cases would look like. And for the less than problems, the special cases were no solutions. That's not the case here. No solution isn't going to be the answer, because in each one of these kind of examples, this side right here, because the whole side is being squared, it's always a positive number, and a positive number is always greater than whichever negative number is over here. The answer is going to be every real number. It's every number between negative infinity and positive infinity. Whereas the special cases with the minus, special case with the less than, that we did in the first half of this, like x squared less than negative 9, or x minus 7 squared less than or equal to negative 16, these had no solution. Because a positive number, that's what this left side was always going to reduce to. No matter what number you plug in for x, the left side's going to reduce to a positive number, and a positive number is never less than a negative number. So you can never get anything works. Whereas here, no matter what I put in for x, when I square it, it becomes positive, and a positive is always bigger than a negative. So they're kind of opposites in the special cases. And again, like if I was doing any one of these 4 problems, like if I was doing this problem, the first step I would do, so if I was solving x squared is greater than negative 9, the first step that I would do is I'd go x squared equals negative 9, and then I'd go square root plus or minus square root. This would give me x equals plus or minus 3i. And immediately when my algebra leads me to an I know that it's a special case, and I should try to figure out which of the special cases it is. Is it the left side squared greater than a negative number, which means every number works, or is it the left side squared less than a negative number, which means no number works? But you should stop doing your algebra and figure out which special case it is. So that's one thing we need to be concerned about for greater than or greater than equal to problems, which we do in this part of the lecture, are the problems that don't require any algebra, and they're going to look like that. And then the normal problems, like problem 46, that's not a special case, you solve them exactly the same way. So to solve this, just like I solved the problems yesterday, I'm going to go through exactly the same steps. So if it's not a special problem and it has a greater than, step 1, I'm going to solve the problem by replacing the inequality symbol. In this case, the greater than or equal to is the inequality symbol. With an equal sign. And we did a lot of these in the first half. After I do that, I solve the problem. I'm going to plot the two answers. On a number line. That also includes plus and minus infinity. And create my intervals. Square brackets on the or equal to's, round brackets on the non or equal to's, and then I'll go and then create the table. How about create and complete the table? So for problem 46, step 1, I guess maybe I'll cross out, I didn't really write step, but this is what I'm going to do. So first thing I'm going to do is write x squared is greater than or equal to 16, and now I'm going to solve for x by square rooting plus or minus square rooting. That's going to give me x equals plus or minus 4. My number line is going to have negative infinity on the far left edge, positive infinity on the far right edge. The other numbers I'm going to put on it are negative 4 and positive 4. First interval, infinities always get round brackets. Non-infinities get round brackets if there's not an or equal to, get square bracket if the inequality has the or equal to part. And because this is a greater than or equal to problem, the non-infinities get a square bracket. And now my table. Exactly the same table. First column has intervals. My intervals are going to be negative infinity to negative 4, negative 4 to 4, and 4 to infinity. For my test numbers, I just need numbers that are in the intervals, and I don't really want that big of a number. And this interval, negative 5, is in the interval, and it's kind of the smallest number I can pick in some sense. This interval goes from a negative to a positive, so I'm going to plug in a 0. And this interval, I'm going to plug in 5. It's in the interval, and it's not a terribly large number to deal with. And then up here I write the original problem, just like the less thans. And now I'm going to do the algebra. So is negative 5 squared greater than or equal to 16? That reduces to 25 is greater than or equal to 16. Second one, I do 0 squared is greater than or equal to 16. that simplifies to 0 is greater than or equal to 16. And the last 5 squared is greater than or equal to 16 gives me 25 is greater than or equal to 16. And then I write true or false. Top one, 25 is bigger than 16. So that's true. Middle one, 0 is not bigger than 16. So that's false. And bottom one, 25 is bigger than 16. So I'll write true. My answer is the true intervals. So my answer to problem 46 is going to be the interval from negative infinity to negative 4, and the interval from positive 4 to infinity. It's nice when you have two intervals if between the two intervals you put a u, which I read as union, and you can think of the word or. So anything in this interval or anything in that interval will work as an answer. So it's exactly the same. Make an equal sign, solve the problem with the equal sign, create a number line with intervals, put the intervals in a table, figure out test numbers, put the original problem up top, plug the test numbers into the original problem, determine if they're true or false. Your answers are the truths. So the nice thing about these problems from 45 through 88, you start to look at the problems from the beginning with the same problems, except I flipped the inequality. So for the first few problems, I'm going to do a bit more algebra than I eventually will, but I've done most of the algebra already. So I'm going to do 48 all the way out, and then I'll show you problem 4, which was kind of its sister problem, the same problem except with a different symbol. So first step, solve the problem like it had an equal sign. And then I'm going to square root plus or minus square root. So it's going to give me x equals plus or minus. And then I'm going to get a nice radical answer on my calculator. And I'm also going to figure out the decimal because it helps me out. So the nice radical answer is plus or minus 3 square root of 5. And as a decimal, when I hit the SD button, it's plus or minus 6.7. So on my number line, I'm going to put a negative infinity on the far left, positive infinity on the far right, a negative 3 square root of 5, and a positive 3 square root of 5. First interval goes from negative infinity to negative 3 square root of 5, and square bracket here because of the or equal to, and then negative 3 square root of 5 to positive 3 square root of 5, and then positive 3 square root of 5 to infinity. So now my table. The intervals are going to be negative infinity to negative 3 square root of 5, and that's about negative 6.7. I need to know that so when I pick a number to plug in. And then negative 3 square root of 5 to positive 3 square root of 5. That's like negative 6.7 to positive 6.7. And then the last interval, positive 3 square root of 5 to infinity. And that's 6.7 to infinity. And then my test number in the first interval, I need to go smaller than negative 6.7. I'm going to go negative 7. Here I go from negative to positive, so I can use the 0. Here I need bigger than 6.7. I'm going to plug in 7. Throw the original problem up here. X squared is greater than or equal to 45. First one's going to give me negative 7 squared is greater than or equal to 45. That's going to reduce to 49 is greater than or equal to 45. 49 is bigger than 45, so this is my true. Middle one, 0 squared is greater than or equal to 45. Tells me that 0 is bigger or equal than 45. 0 isn't bigger than 45, nor is it equal, so that's false. And then the last one, 7 squared is greater than or equal to 45, which gives me 49 is greater than or equal to 45, and 49 is bigger than 45, so that's true. So my answer is going to be the true intervals. So my answer is going to have two intervals. The top interval, negative infinity to negative 3 square root of 5, and then the bottom interval, 3 square root of 5 comma infinity. The nice thing, if you picked up your work for problem 4 and you laid your work for problem 4 directly on your work for the problem that we just did, look, it's the same, essentially the same problem. The only difference between problem 4 and problem 46 is that if I look at my first steps up before the table, my first step up before the table gives me this number line, because I solved by changing the greater than sign or the less than sign to an equal. First step's the same. Second step I square rooted, I got the same. Third step, the number line's the same. Fourth step, the beginning of the table's the same. The test number's the same. Where the numbers I even plugged into the inequality are the same. The only, look at this, I have 49, 45, 0, 45, 49, 45. The only thing different algebraically between problem 46 and problem 4 is this part right here, because the only thing different is what I'm comparing. Here, I need a smaller number to be true. Here, I need a bigger number for it to be true. So the only difference between the problem that I just did and the problem that I did yesterday is right there and right there. The algebra is 100% the same, except for when I get to the very end of my table. I'm going to do one more problem kind of full out, and then I'm going to start getting lazy and I'm going to just doctor up my work. So from that I did yesterday. So first step, make this an equal. So I'm going to get x squared equals 49. Then I'm going to square root plus or minus square root. It's going to give me x equals plus or minus 7. So on my number line, I get a negative infinity, a negative 7, a positive 7, and a positive infinity. I get round brackets on the 7s because I don't have the or equal to, or round parentheses on 7 and negative 7 because I don't have the or equal to. Now my table. The intervals I'm going to use are negative infinity to negative 7, and then negative 7 to 7, and 7 to infinity. In the first interval, I need a number in this interval. I pick one close to the end. I'm going to pick negative 8. The second interval goes from negative to positive. I'm going to pick 0. Any interval that goes from negative to positive, I pick 0. The last interval, I don't want to get too big of a number. I'm going to pick 8. And I'm going to write the original problem. X squared is greater than 49. And now I'm going to go, is negative 8 squared greater than 49? That gives me 64 is greater than 49. And that's true. 64 is certainly bigger than 49, so I'm going to write true there. Next one, 0 squared is greater than 49. Says 0 is bigger than 49, and that's definitely false. And then the last one, 8 squared is bigger than 49. Gives me 64 is bigger than 49, and that's true. So my answer is going to be the interval from negative infinity to negative 7, union the interval from 7 to infinity. And I completely designed this section with the hopes that when you got to the greater than problems, you would start to speed up the process. Because when I look at problem 6 and compare it to problem 50, problem 6 and problem 50 both have x squared compared to 49. The only difference is problem 50 has a greater than, problem 6 had a less than. But for greater than and less than, look at my first step, solving the equation with an equal sign, square rooting plus or minus square rooting, doing a number line. The first step is exactly the same. This chunk right here for number 50 and this chunk right here for number 6 are exactly the same because I change, regardless of if it's a less than or greater than, I change it to an equals to. So that step's going to be the same. And then when I look at my table for problem 6 compared to my table for problem 50, interval column the same. I pick the same check numbers. I plug them in the same. The big difference is here I have the problem 6 with a less than. Here I have problem 50 with the greater than. And how do I, and even this is kind of the same, except now the less thans in problem 4s get replaced by the greater thans. So what was false before becomes true now. What was true before becomes false now. Because in problem 4, I needed a number less than 49 to be true, and that was the middle one. And the top ones weren't less than 49, so they were greater than 49. And in problem 50, I need a greater than number greater than for it to be true. So that works exactly the same for every one of the end problems as the work that I've already done, except right here is where it starts to vary. And what varies on this step is just this sign, and that makes all of these flip too. So now I'm going to start to be efficient, hopefully. When I do problem 52, I've already done problem 8. So at a minimum for being efficient, I know my first step was to go x squared equal to 24, which I've already done. So I've solved this and I've created my number line. And so I'm going to take, I'm not going to do anything. I'm going to be more efficient than that. So up through here, I would go square root plus or minus square root. This would give me x equals plus or minus the square root of 24, and the square root of 24 is 2 square root of 6, which I already did when I did problem 8. And that's going to make me put negative 2 square root of 6 and positive 2 square root of 6 on the number line with infinities on my edges. I'm making my intervals. They get round brackets because I have no or equal to. And so all the way up to here, problem 52, which wants me to do x squared is greater than 24, will have exactly the same algebra. So all this that I did for problem 8 up until what I have covered up by my calculator is exactly the same for problem 52 as it is problem 8, because they're exactly the same except they're flipped. So if I just copy my work for problem 8 that I already did, or get another color pencil and write over my work, that's what I'm going to do. And I'm going to now call this problem 52. So this, I'm not going to do separate work for 52 because I've done all the grungy work. I'm going to cross out my answer for 8 and replace it for an answer for 52. The only difference between 52 and the problem 8 is that this should be x squared is greater than 24, which changes this column. Changes that less than to a greater than, changes that less than to a greater than, changes all the less thans in this column to greater thans. Now I have to figure out which one is true and which one is false. It's not terribly hard. In problem 52, I need 25 to be, I need this number to be bigger than 24 for it to be true. And 25 is bigger than 24, so I get a true here. In the middle one, I need this number to be bigger than 24. 0 is not bigger than 24, so I get a false. And in in the bottom one, I need the number here to be bigger than 24, and 25 is bigger than 24, so I get a true. So my answer to problem 52 is going to contain two intervals. The interval is going to be the top interval, negative infinity to negative 2 square root of 6, and the interval from 2 square root of 6 to infinity. And that's all there is to do. So if I had the work for number 8 done, then the work for 52 is easy. 54 is a special case. It's a special case because the left side is a perfect square, the right side is negative. If I tried to solve it, I'd go x squared equal negative 16. Then I'd go the square root of x squared equals plus or minus the square root of negative 16. That's going to give me x equals plus or minus 4i. And immediately I knew it was a special case. And the special cases for greater thans, you get every number works, because this is always a positive number. No matter what you put in for x, when you simplify that side, it becomes positive. Positives are always bigger than negatives. My answer to 54 is going to be negative infinity to infinity. Whereas its kind of twin problem, problem 10, it was the same setup, except it was a less than, and you can never have a positive number less than a negative number, so I get no solutions. So special cases with less thans, there's no solutions. Special cases with greater than, every number works. So next year are going to be special cases, I think. 56 is equally a special case because I have the left side being squared, the right side being negative, so this is the special case problem. If I tried to solve it, I'd get an I. If I did x squared equals negative 45, I'd go square root plus or minus square root, break out my calculator, square root of negative 45 is going to give me an I. And I know that makes it a special case, and this is a special case with a greater than, so the answer is going to be negative to positive infinity. '58's another special case. Again, if I tried to solve it by going x squared equal to negative 49, the square root of x squared equals plus or minus the square root of negative 49, you get x equals plus or minus 7i. Immediately when I come up with the I know that it's either every number works or no number works. Left side squared, the right side negative with a greater than, the answer is going to be negative to positive infinity. If that was a less than, you'd get no solution. So when I did problem 14, I just said that's a special case. It's a special case with a less than, and there's no solution. Same deal between 16 and 60. This is a special case with a greater than, so every number works. The complement of this, the special case with a less than, you had no solution. 62 and 18 went together. 62 and 18, the left side squared, so anything squared, no matter what number you put in for x, reduces to a positive number. In 18, I needed to have the left side less than the right side, but a positive number can't be less than a negative number. But in 62, the left side reduces to some positive number, and a positive number is always greater than or equal to negative 16, so the answer is negative to positive infinity for 62. '64 is essentially the same problem as 64 is, it's not a special case anymore. 64 is, it's not related to one. I'm surprised. But it's not a special case. Maybe I missed something, but I'm going to do this all the way out. It's not a special case because that's a positive. So I'm going to solve x minus 9 squared equals to 16. And then I'm going to go the square root of x minus 9 squared equals plus or minus the square root of 16. This is going to give me x minus 9 equals plus or minus 4. I'm going to add 9 to both sides. That's going to give me x equals 9 plus or minus 4. That gives me x equals 9 plus 4, or x equals 9 minus 4. The 9 plus 4 is 13. The 9 minus 4 is 5. So on my number line, I need a negative infinity, a positive 5, a positive 13, a positive infinity. First interval is going to go from negative infinity to positive 5, square bracket because of the or equal to. Middle, positive 5 to positive 13, double square brackets. The last one, positive 13 to infinity. So my table is going to go from negative infinity to positive 5, from positive 5 to positive 13, and positive 13 to infinity. And then next to it I put my test number. Here this goes from a negative to a positive. That's where I like to put in 0. Between 5 and 13 I'll plug in 6. Bigger than 13 I'll plug in 14. Now I'm going to put the original problem, x minus 9 squared is greater than or equal to 16. First one I'm going to go 0 minus 9 squared is greater than or equal to 16. Middle one I'm going to go 6 minus 9 squared is greater than or equal to 16. Last one, 14 minus 9 squared is greater than or equal to 16. I use my calculator now. So for the first one, can you make it so you can see it? Well, I think so. So first one, I'm going to go 0 minus 9 squared. That's going to give me 81 is bigger than or equal to 16. And since 81 is bigger than 16, I'm going to write true. The next one, I did 6 minus 9 squared. And to do 6 minus 9 squared, you get 9 is bigger than or equal to 16, and 9 is not bigger nor equal to 16, so that's a false. And the last one, I'll delete that 14, delete the 6, change it to a 14, and get 25 is bigger than or equal to 16. And that's true. So my answer is going to be the top and the bottom interval. And so my answer is going to be the top interval from negative infinity to positive 5, and then again the bottom interval from 13 to infinity. If you want to gamble and be lazy, if it's not a special case and it's a greater than, it's the top and the bottom interval that are going to take you to the answers. That's going to be for every problem that has a square that we do. I think in general, every problem, every quadratic inequality, a square with a greater than sign is going to map out like this. This strategy can work for cubes, fourth powers, it can work for fractions. And once you start varying the exponents on the x's, then it's not as consistent what your answer is. I don't see a pair yet for 66. So let me move on and do this regularly then. So maybe there was one and I'm just not seeing it. I'm going to go x plus 5 squared equals 36, and then square root plus or minus square root. This is going to give me x plus 5 equals plus or minus 6. I'm going to minus 5 from both sides and get x equals negative 5 plus or minus 6. It gives me x equals negative 5 plus 6, and x equals negative 5 minus 6. Negative 5 plus 6 is a positive 1. Negative 5 minus 6 is a minus 11. So my number line is going to have negative infinity, negative 11, positive 1, and positive infinity. Intervals get all round parentheses because I don't have the or equal to part. Those are my three intervals. Make my table now. First is going to be negative infinity to negative 11. Second's going to be negative 11 to 1. Bottom's going to be 1 to infinity. In this interval, I'm going to check negative 12. This interval goes between negative and positive, so I check 0. That interval, I'm going to check 2. And what I'm going to check them into is x plus 5 quantity squared is greater than 36. The first one, I'm going to go negative 12 plus 5 squared, see if that's bigger than 36. Then I'm going to do 0 plus 5 squared, see if that's bigger than 36. And then I'm going to do 2 plus 5 squared and see if that's bigger than 36. I can do these in my head, but since I have a calculator that does them so well, I'll use my calculator. So for the first one, parentheses, negative 12 plus 5 parentheses squared. This gives me 49 is bigger than 36, and 49 is certainly bigger than 36, so I get true. Now I'm going to get rid of that negative 12, change it to a 0. 0 plus 5 squared gives me 25 is bigger than 36, and 25 isn't bigger than 36, so that's false. And then the bottom one, I get 49 is bigger than 36 again, and that's true. So if on these problems you just want to start gambling and not doing all the work in the table, on the greater thans you get a true, false, true. On the less thans you get a false, true, false. It's going to work for all of our problems. It's not a coincidence because they're all kind of the same style of problem. They all kind of table-wise work the same way. So my answer to this is going to be from negative infinity to negative 11, union 1 to infinity, all round brackets. Oh, 68 just kind of snuck up on me. That's a special case because the left side is squared, the right side is a negative number. If it was a less than between these two, I'd say it's no solution. But because it's a greater than, it's a every number. It's a special case because the left side is squared and the right side is a negative number. And in special cases with greater thans, the answer are negative to positive infinity. Special cases with a less than, the answer is no solution. Finally getting back on track. I don't know what happened, but I must have changed some things up. So problem 70 and problem 26 are going to be brother problems. I'm just going to do a few more problems and then maybe even stop the section short of doing every single problem. But let me do problem 70 full out, pretend like I don't have problem 26 that I could just steal the work from. So for problem 70, I'm going to go x squared plus 5x minus 6 equals to 0. And factor this into x plus 6 times x minus 1 equals to 0. Go x plus 6 equal to 0. X minus 1 equal to 0. This gives me x equals to minus 6. X equals to 1. My number line has a negative infinity, a negative 6, positive 1, and a positive infinity. Square brackets on the negative 6 and 1 because they are equal to. Infinities always get round brackets. I think the answer is going to be this. I'm going to confirm it in my table. I think the answer is going to be negative infinity to negative 6, union 1 to infinity. Let me do the table to make sure. I'm going to go negative infinity to negative 6, negative 6 to positive 1, and then positive 1 to infinity. This interval I'm going to check negative 7. This interval goes from negative to positive. I'm going to check 0. This interval I'm going to check 2. And I'm going to check them into x squared plus 5x minus 6 is greater than or equal to 0. So first one, negative 7 squared plus 5 times negative 7 minus 6 is greater than or equal to 0. Calculator time. So negative 7 squared plus 5 times negative 7 minus 6. I messed up there. I didn't do negative 7 squared. I did negative 79 squared. Let me get this 9 out of here, make it a parentheses, and that is going to give me 8 is bigger than 0, and it is, so this is a true. The next one I'm going to do 0 squared plus 5 times 0 minus 6 is greater than or equal to 0. It's going to give me minus 6, but let me just do it just so I'm not thinking wrong. And when I do this, I get minus 6 is bigger than or equal to 0. A negative number is not bigger than 0, so that's false. And the bottom one, 2 squared plus 5 times 2 minus 6 is greater than or equal to 0. Apparently I haven't recovered from my lecture yesterday. I'm still kind of fudging it. Good. So that, what I thought was an answer is an answer. And what I probably should have done is I probably should have just taken problem 26, crossed out the 26, changed it to a 70, changed the less than to a greater than, which is going to change each one of these from less than or equal to's to greater than or equal to's. All the work here is the same, all the work there is the same. The only difference is the comparison that I'm doing, instead of it having a less than or equal to, has a greater than or equal to. And what that does is it changes this two parts. It changes false to trues and trues to false. Because in the problem that I just scratched out, I wanted small numbers smaller than 0. Here I want numbers bigger than 0. I'll just do a couple more, and then I won't finish the section. So if I look at problem 28 had these lovely intervals with a false, true, false. I think my answer is going to be true, false, true, and my answer is going to be those. So stealing from 28, I think my answer, without doing a lick of algebra, is going to be the interval from negative infinity to negative 10, union the interval from 5 to infinity. And let me do it full out for you. So first step, I go x squared plus 5x minus 50 equals to 0. This factors into x plus 10 times x minus 5 equals to 0. Then I do x plus 10 equal to 0, x minus 5 equal to 0. This one gives me x equal negative 10. That gives me x equal positive 5. On my number line, I get a negative infinity, positive infinity, a negative 10, positive 5, square bracket on the negative 10 and the positive 5 because of the or equal to. Create my table. First column is going to have negative infinity to negative 10, and then negative 10 to positive 5, and then positive 5 to infinity. I'm going to check negative 11 here, because it's kind of close to the edge. Here you go from negative to positive, so I check 0. There I'm going to check 6. I'm going to check them into x squared plus 5x minus 50 is greater than or equal to 0. So I'm going to go negative 11 squared plus 5 times negative 11 minus 50 is greater than or equal to 0. Let me do that one. So that's going to give me parentheses negative 11 squared plus 5 parentheses negative 11 minus 50. That gives me 16. Positive 16 is bigger than 0 or equal to, and that's true. For the next one, I'm going to go 0 squared plus 5 times 0 minus 50 is greater than or equal to 0. So now I'm going to change my negative 11s to zeros. It's going to give me negative 50, I guess. This tells me negative 50 is either bigger than or is equal to 0. And that's false. In the bottom interval, I'm supposed to put in 6. So let me do that. Change those zeros to 6s. And I get 16 is bigger than 0 again, and that's true. And the true intervals are my answer, and that's what I thought was going to be the answer, because I had problem 20, which was the same problem with a less than or equal to. When I flipped the less than or equal to, in the less than or equal to, the middle interval is true, and the greater than or equal to, the top and the bottom intervals are true. (74) and 40 are essentially this. 74 and 30 are essentially the same problems. So I think the outside intervals are going to be true in the problem I'm about to do, because in a less than, the middle interval is true, and a greater than, the outside intervals are true. So I think the answer is going to be negative infinity to negative 1/2 union 3/2 to infinity. Now I'll do this again just because it's a quadratic formula, because I don't want to factor this. So I'm going to go 4x squared minus 4x minus 3 equals to 0. Quadratic formula, a equals to 4, b equals to negative 4, c equals to negative 3. I'm going to go negative b plus or minus the square root of b squared, putting negative 4 in for the b's, minus 4, and then a is 4, then c, which is negative 3, all over 2a, which is 2 times 4. Calculator time. So fraction negative parentheses negative 4 plus square root negative 4 in a parentheses squared minus 4 parentheses negative 3 all over 2 parentheses 4, and I get positive 3/2, which is there. Now I'm going to back into the quadratic formula work and do the minus part of the plus or minus. So I get my cursor flashing next to the plus sign, delete, make a minus sign, and I get the other answer of negative 1/2. So those numbers go on a number line. You go from negative infinity to negative 1/2, and then positive 3/2, and then positive infinity. All round brackets in this problem, because there isn't an or equal to. The infinities always get round brackets, and the numbers get round brackets if the problem doesn't have an or equal to. So my table's going to start off with negative infinity to negative 1/2, and then it's going to go from negative 1/2 to positive 3/2, and then it goes from positive 3/2 to infinity. In this one I'm going to check negative 1, that's kind of close to negative 1/2, but so smaller than it. Middle interval goes from negative to positive. I check a 0. Here 3/2 is 1.5. I'm going to check 2. And I'm going to check them into 4x squared minus 4x minus 3 is greater than 0. So I'm going to go 4 times negative 1 squared minus 4 times negative 1 minus 3. See if that's greater than 0. Do the same with the 0. 4 times 0 squared minus 4 times 0 minus 3 is greater than 0. And then work the 2. 4 times 2 squared minus 4 times 2 minus 3 is greater than 0. And then I use my calculator. You can do these by hand, but it's so much easier and more accurate when I'm using my calculator that I don't even think to do them by hand because my calculator is so easy to use. So top one is that, and that gives me 5 is bigger than 0. And since 5 is bigger than 0, I'm going to put a true here. Now I'm going to get rid of these negative ones in the parentheses and put zeros there to check the middle. And that gives me negative 3 is bigger than 0. And that's false. And the bottom one, I'm going to change the zeros now to a 2. That's going to give me 5 is bigger than 0 again. So that's another true. And my answer that I predicted, the top and the bottom interval, was good. And again, when you have two essentially identical problems, if one has a less than and the other has a greater than, their answers are opposite from each other. So in problem 30, the answer had the middle interval because it had a less than. It had to be the case in 74. Same problem with a greater than, you get the opposite intervals. Okay, let me do another one, and I'm getting close to just saying we're going to just be lazy. And maybe I'll even be a little bit lazy here and just take the outside intervals and gamble that they're right. And that's what I did on when I did problem 32, which 32 and this are essentially the same problem. So my guess is, because 32 and 76 are essentially the same except with the flip signs, I think those are going to be my answers. And let me just write that down since I have that handy. I think the answer is going to go from negative infinity to negative 2, and then from negative 3/2 to positive infinity. Let me do the algebra again here. A is equal to 5, B is equal to 3, C is equal to 6. I'm going to go negative B, which is negative 3, plus or minus the square root of B squared, which is 3 squared. When the B's positive, it doesn't need to go in a parentheses, but it's okay too. Oh, I'm supposed to put 13. I forgot. That's supposed to be 13. This was supposed to be 13, so it's supposed to be negative 13 plus or minus the square root of 13 squared. For whatever reason, I forgot the one part of the 13. So negative B, negative 13, plus or minus the square root of B squared, 13 squared, minus 4AC, which is 4 times 5 times 6, all over 2A, which is 2 times 5. Break out my calculator. Fraction, negative 13 plus square root 13 squared minus 4 parentheses 5 parentheses 6 all over 2 parentheses 5 gives me negative 3/5. Now I'm going to back up, get next to that plus sign, delete, change it to minus, gives me negative 2. So what goes on my number line would be a negative infinity, then a negative 2, then a negative 3/5, then a positive infinity. I need the square brackets here because of the or equal to, so I'll go negative infinity to negative 2, negative 2 to negative 3/2, and then negative 3/5 to positive infinity. If I'm doing my table, I have to be a little bit precise about what I check, I guess. The top interval, I'm going to check -3. The middle interval goes from -2 to -3/5. The only nice number between those is -1. And the bottom one goes from a -3/5 to a positive infinity. That's where the 0 lives. Checking, I'm going to go 5 times -3 squared plus 13 times -3 plus 6 is greater than or equal to 0. And then 5 times -1 squared plus 13 times -1 plus 6 is greater than or equal to 0. And then 5 times 0 squared plus 13 times 0 plus 6 is greater than or equal to 0. So, first one, 5 parentheses -3 squared plus 13 parentheses -3 plus 6 gives me 12 is bigger than or equal to 0. That's true. Now I'm going to change the -3's to -1's to do the middle one. And that gives me -2 is bigger than or equal to 0. No, a negative number is not bigger than or equal to 0, so I get false. And now I'm going to change the -1's to 0's to check my bottom one. And that gives me 6 is bigger than or equal to 0, and that's true. So my answer that I thought would be my answer is correct because the top interval is true, the bottom interval is true, and that's what I wrote in my answer. And that's the case for the greater thans. That's kind of what you get. 78 was kind of messy. Let me even do something by hand here. So for 78, I'm going to go x squared plus 5x minus 4 equals to 0. I'm going to go a equal to 1, b equal to 5, c equal to -4. I'm going to go negative b, which is -5, plus or minus the square root of b squared, which is 5 squared, minus 4 times a, which is 1, times c, which is -4, all over 2a, which is 2 times 1. Under the radical, 5 squared is 25, and in the multiplying you get a double negative, which gives me a 16, which gives me a 41 under the radical. I get -5 plus or minus the square root of 41 over 16, which is -5 plus the square root of 41 over 16, and -5 minus the square root of 41 over 16. My calculator, when it does this one, it gives me this. It goes -5 plus the square root of 41 over 16. It kind of factors the negative out of the numerator. Let me show you these on my calculator. So on my calculator, to do this, fraction -5 plus square root 5 squared minus 4 parentheses 1 parentheses -4 over 2 parentheses 1. There's the -5 plus 40 square root of 41 over 2. I don't know why I started writing 16, because 2 times 1 is 2 over 2 over 2 over 2. That's why I use my calculator, because I do moronic things when I don't. Now I'm going to back up, change the plus to a minus, and then I get that. See how the calculator drags the negative there? That means this. By hand you get this. My calculator factors this negative out, puts it in front of the fraction, and writes the opposite of -5, which is +5, the opposite of negative square root of 41, which is positive square root of 41. So on my number line, I would get a negative infinity. This one is smaller, so I'm going to get -5 minus the square root of 41 over 2. This one is bigger, -5 plus the square root of 41 over 2, and then infinity. So I get one interval, middle interval, last interval. I'm going to cheat and just not do my full out table and I'm just going to take the first interval and the last interval for my answers. And if you wrote the calculator version of the interval with the negative factored out, I'm completely fine with that. Now I'm going to write down what the middle interval is. It's not going to be part of my answer. And my answer to this is going to be negative infinity and minus 5 minus the square root of 41 over 2 union negative 5 plus the square root of 41, can't even write right now, over 2 comma infinity. I gambled without making a table. I think that's a safe gamble to do. There's no trick problems in this section other than the special problems that have no solutions or all solutions. I think this will be the last one I do. And then the next few that I haven't done, 82, 84, 86, and 88, you can, if you can't figure them out, the 1, 2, 3, 4 problems I'm going to skip. In fact, let me do 82 because it's easier. And for 80, I'll write the answer down because for 80, I did the work that I needed to do for problem 36, and 36 and 80 were the same. The numbers this was the number line I got for 36. So let me copy that down. So from 36, the number line went from negative infinity to negative 5 minus the square root of 65 over 10 to negative 5 plus the square root of 65 over 10, and then to infinity. So that's because the first step on 36 is to take this problem and make it an equal sign. I do the quadratic formula, it would be the same. I'm just going to roll the dice that my answers are these intervals, and I'm going to write them down, even without writing them on the number line. So my answer is going to be negative infinity to negative 5 minus the square root of 65 over 10. My calculator for this would have written negative and then 5 plus the square root of 65 over 10. I'm content with that. Just when you do it by hand, you get that version of the answer. And then I'm going to write the last interval and gamble that that's right. Usually on greater thans, the outside intervals work, and less thans, the middle intervals work. All right, one last problem. And then if you need to see more, come visit me. I'll do more for you. When I look at problem 82 and I look at problem 38, they're essentially the same problems. The number line that I got for 38 is going to be the same as the number line I get for 82. I believe my answer is going to be those outside intervals. Now, full out do it. The outside intervals are negative infinity to negative 6. And 1 to infinity. So I'm going to do it all the way out and hope those are the answers. So I'm going to go x squared plus 5x equals 6, and then x squared plus 5x minus 6 equals to 0. Factor that into x plus 6 times x minus 1 equals to 0. Then do x plus 6 equal to 0. You get x equal to negative 6, x minus 1 equal to 0, x equal to positive 1. So I'm going to get negative infinity, negative 6, positive 1, positive infinity on my number line. I'm going to need some square brackets on the negative 6 and the 1 because of the or equal to. Create my chart. First interval, I'm going to check negative 7. Second interval goes from negative to positive, so I can check 0. Last interval, I'm going to check 2. And I'm going to go, is negative 7 squared plus 5 times negative 7 greater than or equal to 6 by going to my original problem. And then is 0 squared plus 5 times 0 greater than or equal to 6. And then is 2 squared plus 5 times 2 greater than or equal to 6. So first one, parentheses, negative 7 squared plus 5 times negative 7. That gives me 14. And 14 is bigger than 6, so this one picks up a true. Now I'm going to change those 7's to zeros. This gives me 0 is bigger or equal to 6, and 0 isn't bigger than 6. It's not equal to 6, so that's a false. And I'll do the bottom one by changing the zeros to 2's. Not 22 though. That gives me 14 is bigger than or equal to 6, and that's true. So my guess of an answer was correct. The top interval and the bottom interval are the true intervals. I'll write answers for the next few problems just so you could have them, and I'm going to steal the work that I've done. So problem 40 and 84 were essentially the same problem, which means the intervals on the number lines are going to be the same. It's just the true intervals are different. So on 84, I think the answer is going to be negative infinity to negative 2 union 6 to infinity. If you want me to work it out, come visit me or shoot me an email and I'll write up a solution and email it to you, or we can do it together in my office. So I'm going to skip 84. I'm going to skip 86. And 86 looks just like 42. And so the intervals, this interval here and that interval there should be the true intervals. And that interval, I believe, is the interval from negative infinity to negative 1 minus the square root of 10. And this interval is negative 1 plus the square root of 10, comma, infinity. And again, if you need to see the details, please visit me. I will get you the details. And then 88 is, again, essentially the brother problem of 44. The numbers that go on that went on the number line when I did 44 were negative infinity, 5 minus the square root of 57 over 2, 5 plus the square root of 57 over 2, and infinity. I'm going to gamble on the outside intervals of negative infinity, 5 minus the square root of 57 over 2, and 5 plus the square root of 57 over 2, comma, infinity. If you're taking Math 151 or any calculus course, you should really, really focus hard on this section and get used to making the tables, checking from the tables, because you'll do that a lot in calculus, a little bit in college algebra, and in both of those classes, the problems are a little more advanced in that you just can't look at the problem and know that, oh, the middle part of the table is true, or the top and the bottom one from the table is true. So, you know, really focus on nailing how you make the tables, how you figure out what's true and what's false, and it'll pay off, especially in calculus. In college algebra, we do problems like this where it's not always true, false, true, and if you just, rely on, on a greater than, the trues are the top and the bottom one, on the less than, the trues in the middle, that's going to sell you short in college algebra. It's going to sell you short in calculus. So for us, we're just kind of introducing this topic. We can get a little bit lazy, but you can't be lazy if you're going higher than this. All right, so if I sold you short and you need to see some more, let me do them for you.